Welcome to another exciting educational video brought to you by Upvision Concepts Academy. So in this video, we'll be looking at calculations based on frictional force in physics. From all the exams for senior high, NECO, WAEC, JAMB examinations. So sit tight even as we present the video to you. On the board we have the first question. A 2 kg mass rests on a horizontal surface. If the limiting frictional force is 10 Newton and the gravity is 10 meter per second square, find the coefficient of static friction. Okay, first of all, we will draw a diagram to represent this. This is the ground level. And we have this body of mass 2 kg. This is the body of mass 2 kg resting here. Now, there's a force acting here, which is the mg due to gravity. That's the force that is due to this mass. And the static friction is what is preventing this thing from moving. So we call it limiting frictional force, FLM, F subscript LM, limiting frictional force. This force is preventing body from moving like this. So it is actually given as frictional force, limiting frictional force is equals to coefficient of static friction and reactional force. Okay, of course, let me define it. This is limiting friction, okay, and this is the coefficient of static friction, coefficient of static friction, and the R is reactional force that is due to the weight of this body, reactional force. Okay, so we have this and this, but we don't have this. So it's simple. Let's come here and solve it. So if this is the formula, limiting friction is given as 10 Newton, and the reactional force is given as, okay, this one is not given. We're looking for this one times reactional force R, which is 2 times 10. 2 times 10. That's converting this mass 2 kg to the force, the weight. So 2 times 10, which is 20. So static friction is given as 10 over 20, which is given as 0.5. So that is the unit. The value of static friction. You know that it doesn't have units. It's just unitless. Okay, so we'll go to the next question. Okay, so we have another question on the board. This is actually gotten from WAEC 2014, sorry. WAEC 2014. Okay, it says a 5 kg body is pulled by F. So this is the force pulling it. Accelerates at 2 meters per second and experience frictional force of 5 Newton. Calculate the net force. Number 2, kinetic friction coefficient. Okay, net force and the value of this F that is pushing it and the kinetic friction coefficient. Okay, most times you just have to draw diagram to depict what is going on. This is the 5 kg body that is moving at 2 meters per second. Of course, this body will experience a reaction. That reaction is the weight of the body. We're told that a force is trying to push this, and there's a limiting force going this way. So this limiting force is the frictional force, and the force F is the force that pushes it. So when this force pushes it, okay, let me call it limiting. Yes, limiting. Then there's a resultant. This resultant is the MA. By formula, this force F minus the limiting F limit. This F limit is this F we're trying to look for. Okay, minus F limit is equals to MA. Difference between these two of them, this force, the force that pushes it, and the frictional force limiting it, difference is known as the net force. So this net force, MA, F minus F limiting is equals to MA. MA is mass times acceleration. So that net force is 10 Newton. That's the first one. The net force is 10 Newton. The difference between the frictional force, the force pulling it and the limiting force is 10 Newton. Okay. So we have gotten the net force, and the net force, that is 10 Newton, is the difference between the force that will pull this thing like this and the limiting force, the difference. That limiting force is the frictional force. The next one is to look for F. F is this one that we have here, and we already know that there's a limiting force, and to give us 10 Newton. That limiting force is actually 5. That is the coefficient of friction. Coefficient of friction. That's force, the coefficient of friction that limits the frictional force that limits this body from moving. Okay, so F is equals to 10. Then when some goes up is plus FLM. And F is equals to 10 plus FLM is actually 5. So F is 15 Newton. So I've gotten F. Now the kinetic friction coefficient is gotten from F is equals to mu R. This coefficient is what we are looking for, and we know that reactional force is gotten from the weight of this body. The weight of this body. So we can confidently say that the mu, that is limiting friction, is equals to coefficient of friction is equals to 5 all over reaction, which is 10. Sorry, 50. 50. Why is it 50? Let me explain at this point, at this side. Okay. Let me explain here. Reactional force is actually the weight of that body, and the weight is mass times acceleration, then times gravity again. So 5 times 2 is 5 times 2 is 10. 5 times 2 is 10. That's the weight. Sorry. 5 times 10. 5 times 10, sorry. 5 times 10. 5 is the weight, is the mass, and 10 is gravity given here, right? So reactional force is actually 50 Newton acting down. And the frictional coefficient we are given here as 5 already. Where is the 5? That's this 5 here. So therefore, coefficient of static friction, that is the ratio, is the frictional force, which is 5, over the reactional force, which is 50. So coefficient of friction is 0.15. 0.10. It's actually no units, and it's just a ratio of the two forces. Okay, so we have gotten the net force. This is the net force. Net force. We've gotten net force. Then we have gotten the force that pushed this body, that overcame the limiting force, and now we have now gotten the coefficient of friction. So let's go to the next question. Okay, so I have this question on the board. It says, which statements are true about sliding friction? This JAMB 2000. Now, why I'm bringing this one, this question is actually conceptual, but often calculation based. We see that from here you can actually know how to interpret questions when you're calculating. So this question, I needed to put it up for us to see. So which of the statements are true about sliding friction? Now, the first of all, it is independent of surface area. So it's not dependent on area. So that one is true. Okay, that one is true. Secondly, it depends on the surface nature. Now, area and nature is separate things. Separate things. If you have a smooth surface, you understand, the friction is less. But if you have a rough surface that can also add to the opposing force, the friction is higher. You understand? So smooth surface have less friction, and rough surface have higher friction. Okay, so it does not depend on speed. It does not depend on speed. So this one is wrong. It does not depend on, there's nothing like speed in the formula, but it depends on, it's proportional to the normal reaction. Normal reaction is actually reaction that has to the force that takes the body downwards. That is the weight of the material. So number 1, 2, and 4 are true about static friction. Friction about sliding friction. Okay, so here I have another question on the board. It says a block of mass, a 0.5. This is the mass of the block, 0.5 kg, is pulled on a horizontally. So frictional force is unknown. If it starts moving at this force, so if at a point there's a force that is applied here and start moving at this force, find this one, the coefficient of static friction. Now we're told that for this formula, frictional force, or the force that overcomes friction, is equals to coefficient of static friction times reactions. Okay, now static friction coefficient is actually the ratio between the force that overcame friction and the ratio between this force that overcame friction and reactional force. That is why you don't have it, that it doesn't have units. If I put F over R is equals to static friction coefficient. If I put it like this, these two are force. So that's why it doesn't have units. So please take notes. It's a ratio of two forces. The first force upstairs is the force that overcame friction. You understand? Because how do we know? It said if it starts moving at this. So at this point, it started moving. That means friction has been defeated. All right? So, but we have upstairs as 2.5 Newton, right? But the downstairs, the rational force, we can get it from multiplying this by gravity. All right? Because we cannot use it like this. This is mass in kg. We have to convert it to force, which is the weight. All right? So here we have frictional force as 2.5 all over. Rational force is 0.5, which is the mass, times 10 acceleration. Okay, so I can do this like this, 2.5 over, this is 5, and 0.5 is the coefficient of static friction. All right, so go to the next question. Okay, so we have a question on the board. It's saying that a 40 kg crate rests on a 45-degree incline with static friction of 0.25. Find a minimal horizontal force to keep it stationary. So minimum horizontal force, let me just draw a diagram. I will take it step by step. It's actually a lengthy one. So I have this incline, this is a horizontal, and this is an incline. So I have this crate, 40 kg. Let me just extend it a little bit. 40 kg, 40 kg. And this is frictional force, small f, and this is the force that is moving in this way, big F. So at a point, I will have the normal N, and this is the angle of incline. Okay, so you agree with me that this normal, there's an opposite force to this normal that is also give me the weight. But then this weight has two components. It has mg cos theta. Mg is weight cos theta. This is along the horizontal, and this other component is mg sin theta along the vertical. So I have a diagram on the board. So we are given that M is 40 kg, 40 kg. Then I have the weight. If this is 40 kg, then the weight W is equals to 40 times 10, which will give us 400 Newton. That's the weight. Mg sin theta is the is down the incline. This is down the incline, and mg cos theta is perpendicular to the incline. Okay, so N is the normal force. N is the normal force. N is the normal force, and this F, small f, is the frictional coefficient, and the horizontal force F is applied along the crate. So our question is to find that force that will keep it stationary. That's this F here. You know, this one is going down like this. Understand? This one is acting up. This one is acting here. This one is acting here. So this force is the one that is going to keep it not moving. So this force should resolve all these ones to keep it at equilibrium. Okay. Now there's a formula I will just share with us. That force that will keep it stationary is known as big F, right? Okay. But we know that this one, this F, is actually coefficient of friction times the normal. Okay, so let's know this formula where it is. So I'm going to be writing out some formula for us to understand what we have done. I'll draw the diagram for us, and I'll define the parameters. So the second step is to resolve the horizontal components. Okay, so since F is horizontal, this F is horizontal like this, is horizontal, its components along the perpendicular and incline will be, okay, so I would say along the incline. Which one is the incline? The incline is this one, right? So the component of F along the incline is F cos theta. So, and the perpendicular to the incline, I have F sine theta. So this is along the incline, F cos theta. This component, this thing has two components. This force has two components, F cos theta and F sine theta. Okay, so having gotten this one now, I'm now going to write the equilibrium equation. That is the equation of this diagram that will make this body not to slip down. Remember I said this force is going down like this. This force is going this way. This force is going this way. This force is going this way. All of them are acting. So which force here will make this thing, to be stable? So along the incline, I have F. Okay, I want to write the equilibrium of forces, right? Okay, so along the incline, let me just put it number 1. There are two force equations I want to write. This first one, along the incline, okay, so I will say F cos theta plus the frictional force, F cos theta, that is the horizontal force, plus this one will give me the weight in the vertical region. Okay, so let this one be equation 1. Then perpendicular to the incline, that is this one. So I have normal is going up now. Normal N is equals to, then the component of the weight that we work with this one is mg cos theta plus, then the component of this F that will work with this one is plus F sine theta. Now for this one, you just know that if it is along the incline horizontal, this O here and cos is horizontal, and along the incline, perpendicular to the incline, that is vertical, I here is vertical. So just, it's a way of knowing it, but there's a complex, it's not complex actually, it's just trig identities Because if you can see a rectangle triangle here, you can know what you're looking for with this particular shape ratio. So I have two equations, number 1 and number 2. Let me go to number 2. Now what I want to do is that I want to marry this one inside here. So where I have this frictional force is supposed to be this one. The frictional force is supposed to be that one. So I'm going to rewrite this this equation introducing mu and n. Mu and n. Mu and n. So I'm going to write equation 1 introducing mu and n. So equation 1, just watch equation 1 now. F cos theta plus, instead of having this one, I will have this. I will have this. So I will have mu n, but n is already defined by this guy here, this second one equation here. So I'll just open bracket mg cos theta plus f sine theta, okay, is equals to, then I'll complete it. You know, I'm writing this equation again. So I've written this one here, then this one is this one, you understand? And this one is the last one, mg sine theta. Okay, so having gotten this one now, I'm going to expand the equation. I'm going to expand the equation and I'll put the values of what I have. So let me take this off. This is the equation I want to work on. From there, I will put what I have as my values, looking for what f is. Already, I can say from here, cos theta, which is cos, what's theta? Theta is 45. Cos 45 is given as 0.707, and sine 45 is the same thing. It's the same thing. Sine 45 is the same thing. Sorry, I'm trying to just get my values. 45 is the same thing as 0.707. Then what again do I need? I need my mass. My mass in the question is given as 40 kg. My mass in the question is given as 40 kg. What else do I need from my question? I have my mu from the question as 0.25. Okay. I have this. I have mu. I have mass. I have gravity. Gravity is 10. Gravity is 10. Gravity is 10. What else? What else? So what I have left is to find f. So I'm going to take off this from the board. I'm sure we have the questions already. I want to just manage the space. So I will take off the question because we are told to find f. F is the only thing that is left there to find f. So I'm going to write the equation again. The equation is f, that's, I'm writing this one, f cos theta plus mu is coefficient of static friction, then mg cos theta, that's this, plus sine theta, close bracket, is equals to mg sine theta. So I can put in all this that I have here. F is what we're looking for. Cos theta is 0.707, then plus mu is already 0.25, yes, 0.25, then open bracket, mg is given as 400, then 400 times 0.707 plus, then sine theta again is 0.707. Okay, do we have, yes, f sine. So f, this is f sine, sorry, plus f sine, right? So f is unknown, then into 0.707, close the bracket, is equals to mg sine theta. Mg sine theta is, mg is 400, and sine theta is 0.707. So at this point now, I have f here, I have f here. So I can just solve the question. I can solve the question, calculating step by step. So this is 0.707f plus, then I open up this bracket. I open up this bracket. I have 0.25 outside, right? Then this one will give me 282.8 plus, then 0.707f is equals to, I can close this one. This is 282.8. 282.8. Okay, so opening up the bracket, this will multiply this will multiply this, and I will collect like terms. I will collect like terms. By the time I do it, I want to get to the point where I will have a simple equation. The like terms are this one and this one. That's this times this. Let me just simplify it for us. So I have f, open bracket, 0.707 plus 0.17675, then plus 70.7. You can walk along with me. It's equals to 282.8. From here on, like from when you get this equation, first of all is to resolve this like this. Know that upward reaction and downward reaction are the same thing. To balance it, what is this? This one is the one that is balancing it. What force will this one be? That this thing will not slide down. There's a force going down here. That's frictional force. There's another weight here. The weights are two components. This force too is also two components. That is why I'm having it in two places. You understand? But everything after you have gotten this and representing the equation is mathematics. Okay, so at this point now, I will still take this off. Our goal is to find f. So by the time we are done, f is equals to 212. 212. Of course, we have considered like term all over 0.88375. So final answer, F is approximately 240 Newton. So this 240 Newton F is the force that will require to keep that body not to slide. This F, this force is the one going to make it stable here. If not, if I have a force here lesser than this value, it will slide, because this small f is frictional force that is pulling this one down. You know, as the plane is increasing in angle, the tendency for it to slip, down will increase. It will increase. You understand? It will increase. Okay, so this force. This force is the one that is opposing this one. Sorry, what is slipping it is this weight, mg, and this other weights again. One of them is sine, and the other one is cos. You understand? This is what is preventing, is making it to slip, because the weight is tilting towards this way. You understand? There's also a number here that's trying to balance it. So if you can get this forces the way it's relating to each other, then writing the equation, you can now find what you are looking for. So we'll go on to the next question. Okay, so we have the question on the board. It says a wooden block of mass 0.5. So the mass is 0.5 kg. Is pulled static friction measured 22.5 Newton. Okay, so the static friction is measured as 2.5 Newton. Okay, 2.5 Newton. So what is the coefficient of static friction? Okay, you know that frictional force is equals to mu n. You understand? The reaction n, or normal, or this is reaction or normal force. Okay, let me change to R. Reactional force or normal force. This reactional force is actually the weight of this guy, of this body. Okay, so and the frictional force is F. Now this is what is required to be overcome for this body to move. So that is what we are given as 2.5 Newton. So if you come here and say 2.5 Newton is equals to, we're looking for coefficient of static friction, and the normal reactional force is the weight, which is 0.5 times 10. Okay, so 2.5 here is equals to static friction coefficient times 5, because 0.5 times 10 is 5. So we can make this original formula, and we have it as 2.5 over 5, which will give us 0.5. So 0.5 is the coefficient of static friction for this particular body. So we'll go on to the next question. Okay, so finally I have this question on the board. This question actually is conceptual, so that we can understand what we're talking about here. It said we should describe a real-world implication why terminal velocity is independent of size, that's based on friction of fluid. You know, friction of fluid, there's what we call terminal velocity, and the terminal velocity is not dependent on size. Understand? Rather, it's influenced by several factors, including shape, understand, density of objects, and the fluid's viscosity and density. So, however, the question here likely refers to why objects of different sizes can sometimes reach similar terminal velocities, or why mass alone does not determine terminal velocity. So, in effect, if we are breaking it down, terminal velocity is actually the maximum velocity an object will reach, before, that is when falling through a fluid like air or water. Air can also be a fluid. Okay, so where the downward force of gravity is balanced by upward drag or air resistance. So at terminal velocity, what happens at this point? What happens at this point? What happens at this point? The gravity, force of gravity is equal to the force of drag. Understand? The force of gravity, gravitational force, let me put it here, gravitational force, now force is equals to force of drag. Okay, so how do I explain this concept now? There is the concept of maybe a fluid here. You drop an object inside here and it starts sinking. It starts sinking. Understand? It's sinking. There's what is making it to sink is gravity, right? But there's also another thing that drag, that is the drag force, that is making this thing to, because the speed here outside is higher than the speed inside. So there's something that is dragging it. You understand? That is dragging it. So you have both drag and gravity. Drag and gravity. So in effect, terminal velocity depends on the balance between gravity and the fluid. That is the drag, the fluid friction. We call it drag or fluid friction. Okay, so while size affects both mass and the surface area, they don't always scale equally. So terminal velocity is not independent of size. Instead, it is the result of how size affects both weight and drag simultaneously. Okay, so at this point, we're going to stop for calculations based on friction. If you like the video, if you enjoyed the video, please like and subscribe to our channel. And I hope this video has been informative for you. I'd like to thank you for viewing.